All right, so we're going to talk about solving equations, and in particular, some types of equations that I notice a lot of people have trouble with or get the wrong answer. So the first one doesn't look very difficult. It's just x cubed equals 4x. And the issue here is a lot of people make a critical mistake. So over here, I'm going to say caution. It's very tempting when you see x cubed equals 4x to then take that equation and say, what if I just divide both sides by x? And that gives me x squared equals 4. And then I know there's going to be two answers, plus or minus the square root of 4. So I get plus or minus 2. And what's happening here, it's not that 2 and negative 2 are not correct answers. They are. How do you tell? You could always plug them back in here, right? And sure enough, 2 cubed, which is 8, is equal to 4 times 2. Negative 2 cubed is negative 8, which is 4 times negative 2. So these are correct answers. The problem is there's another answer that you're not getting if you do it this way. What other number could you cube and it would be equal to 4 times the same number? Don't think too hard. Wouldn't you agree 0 works, right? 0 cubed is equal to 4 times 0. So if we do it this way, we're missing an answer, okay? And where that's coming from was the dividing out the x. So what I want to say about solving equations, generally speaking, it's dangerous to divide out variables. If you want to divide both sides by a number, that's fine. But if you try to divide by a variable, you run the risk of losing answers. So I'm just going to put note x equals 0 is also an answer, right? So you don't want to do it this way. I'm just going to, now that I wrote that, I'm going to say don't want to do it that way. So instead of dividing by x, what could you do? Well, you could move the 4x over, set this equal to 0, and do some factoring. So if I pull out an x, that leaves me with x squared minus 4. So here, if I set this equal to 0, that gives me the x equals plus or minus 2. And here, x equals 0 is my other answer. So I get this, and I get the same two answers here. So yeah, generally speaking, don't divide out variables. Instead, move things over, and you're always better off factoring when you're solving equations like these. Okay. Next problem is an equation with a bunch of fractions. And so the first thing you probably want to do here is factor anything that can be factored. So this can be factored. So we have 3x over x plus 5 plus 1 over x minus 2 equals 7, and x squared plus 3x minus 10. Factors of negative 10 that add to 3 would be x plus 5, x minus 2. Coincidentally, also the same two denominators I have over here. And the issue I see with students on this type of problem is not necessarily not getting the answer, it's just doing a lot more work than needs to be done. You've been trained very well how to combine two fractions with two different denominators, but you don't need to do that here. Remember that this is an equation, and the golden rule of equations, anything you do to one side of the equation, as long as you do the exact same thing on the other side, all is fair and square. So instead of combining these two fractions, wouldn't it be nice if I could get rid of these denominators and not have any fractions? And you can by multiplying both sides of this equation by the lowest common denominator of this whole entire problem is x plus 5 times x plus 2. So if I multiply both sides, on the right side, 7 over this times x plus 5, x minus 2, that's just going to cancel. So we're just going to be left with 7. And on the left side, if I distribute this in, remember when you multiply, think of this as over 1. So this is in the numerator. So if you multiply this times this, your x plus 5s are going to cancel. So you'll end up with 3x times x minus 2. And if I distribute that in here, now my x minus 2's are going to cancel. So I'm just going to have 1 times x plus 5, which is just x plus 5. And see, that looks, just that simple move there in this looks so much better, right? I don't have any denominators to deal with anymore. So now let's just do some algebra here. 3x squared minus 6x plus x plus 5 equals 7. Given that I've got an x squared term, we're going to want to move everybody over and make one side equal to 0. 3x squared minus 5x minus 2. And so this factors into, remember, if your coefficient is not 1, then you can't just think of factors that have -2 that add to -5, but we do know the only way to get 3x squared would be if one factor is 3x and the other one's x. My only factors of 2 are 2 and 1. One's got to be negative, so 2, 1, if that doesn't work, I can flip these around. But yeah, see, if this is -2 and this is +1, that's going to give me -6x plus 1x gives me the -5x. Okay, so this is how it factors. And then if you have 3x plus 1 times x minus 2 equals 0, it means either this is equal to 0 or this is equal to 0. This is going to give you -1/3. And this is going to give you x equals 2. Now, there's one more little catch on this type of a problem that you got to be aware of, is that even though algebraically we came up with these two answers, one of them does not work. And I know it's always a good idea to check your answers by plugging these back into the original problem, you know, but who has that much time, right? It's always a good idea, but at least check this. If I were to plug in 2 into this original equation, what's going to happen right here? I'm going to have 1 over 0, right? It's going to be undefined when x is equal to 2. So there's no way that can be an answer because this would create something that's undefined. So we're going to rule that out. The -1/3 does not make any of these denominators equal to 0. So we're going to go with that as our final answer. Okay, so yeah, try to get rid of denominators. Just multiply both sides by the lowest common denominator, and it's going to be a much faster problem. Okay, another type of problem that you get a lot of questions on is something with a square root in it. So I have the square root of x plus 2 equals x minus 4. And of course, the way to get rid of the square root is you're going to have to square both sides. The square root of something squared is just what's on the inside. Be careful, this is one of the places you can make a mistake. X minus 4 squared is not x squared minus 16. You actually have to multiply that out. Remember that this is the same thing as x minus 4 times x minus 4, which means you're going to get x squared minus 4x minus 4x and then plus 16. So that's going to be x squared minus 8x plus 16. We want to make one side equal to 0. Since I have a positive x squared here, let's move everybody to the right side. If I subtract x from 8x, that's going to give me minus 9x. Subtract 4 from 16, that's going to give me 12. Why did this is 2? I don't know why I put 4 there. Sorry, that's x plus 2. I was probably looking at that term. If I subtract 2 from 16, that gives me plus 14. And then this factors into factors of 14 that add to -9 minus 2 minus 7. And so if you set each of those factors equal to 0, you get either x equals 2 or x equals 7. Now what happens here, what you have to be aware of, is anytime you solve an equation by squaring both sides or cubing both sides or raising both sides to the 4th, you run the risk of getting what we call extraneous solutions, solutions that look like solutions but are not actually solutions. If you're wondering why that's true, think about this. If I had this equation, if I had let's say I had, so this is just a side note, if I had x plus 1 equals 2, how about even just that, okay? How many solutions are there to that equation? Obviously, there's just one solution, huh? X is equal to 1. But if I take an equation like that that has one solution and I decide to square both sides, which is what we're doing here, now I end up with x plus 1 squared equals 4. How many solutions are there to this equation? Hopefully, see, there's 2, right? Because if I had this equation, then I would take the square root of both sides. I would end up with x plus 1 equals plus or minus the square root of 4. X would equal -1 plus or minus 2. There's going to be 2 answers there. But the original equation only had one answer. So it would only be one of these. So that's why whenever you solve an equation by squaring both sides, you sometimes get extra answers that don't solve the original equation, right? -1 plus 2 is 1. -1 minus 2 is -3. So these would be 2 answers, but think about it. -3 plus 1 does not equal +2. So this answer is no good. The only answer that works in this case would be 1. So it's very important when you have these types of equations that you do need to check your solution. So if I plug 2 in here, and you can just do this mentally, 2 plus 2 is 4, square root of 4 is 2, but that does not equal 2 minus 4. That equals -2, right? So this is not going to work. By the way, just a side note too, remember that when you solve an equation by taking the square root of both sides, to get both answers, you do need to put plus or minus. But if someone just says, what's the square root of, for example, 9, it's not plus or minus 3, it's just +3. Okay, so that's why when I plugged in 2 here and got 2 plus 2, the square root of 4 is only 2. It's not 2 and -2, it's just 2. That's why that doesn't work. If x is 7, 7 plus 2 is 9. There we go. The square root of 9 is 3. And 7 minus 4 is 3. So this one actually works, and that is my only solution. Okay, so just be cautious when you're solving an equation by squaring both sides. You might get, what happens, sometimes both answers work. Sometimes neither of these answers work. And then like we saw here, sometimes only one answer works. So just make sure you check your solution.